This is example 7.1 from Discovering Design with Chemistry. The problem says, what is the mass of a single molecule of glucose, C6H12O6? What is the mass of a sample of glucose if it contains 6.02 times 10 to the 23rd molecules? Now, we just learned about a mole, and this number represents 1 mole. So that's going to make that part of the problem easier when we get to it. But let's start with the first question. So to find the mass of a single molecule, we need to recognize that we have 6 carbons. So each carbon has 12.01 AMU, and so we can multiply that by 6. And then we have 12 hydrogen, and each of those is 1.01 AMU. So we're going to multiply that by 12. And then last we have oxygen, and that's 16.00, and we have 6 of those. These numbers right here are what tell us how many of each atom we have. So we just multiply that number by the atomic mass unit that's listed on the periodic table. When we add these up, we have to recognize that we are not really multiplying the 6 times 12.01 because you can't have a portion of an atom. So that 6 is really more like the way multiplication really means is that it's a shortcut to addition. What we're really doing is we're adding 12.01 to itself 6 times. And so then when we think about significant figures, we just have to think about this, how many significant figures 12.01 has, or what level of precision it has, and remember the rules for adding. So when we add, we think, all right, 12.01 is to the hundredths place. So if I add another number to it and it's also precision is to the hundredths place, then my answer needs to be to the hundredths place. All 3 of these numbers in parentheses, these atomic mass units, have their precision to the hundredths place, and so our answer will have its precision to the hundredths place. So we don't have to worry about the multiplying as if it were another significant digit. All right, so we get that this answer is 180.18 AMU, and that's atomic mass units. So that's the answer to the first question. What is the mass of a single molecule of glucose? It's 180.18 AMU. The next question asks, what is the mass of a sample of glucose if it contains 6.02 times 10 to the 23 molecules? In other words, what is the mass of 1 mole of glucose? Because this number is 1 mole. This number on the atomic table, on the periodic table, underneath each of the atoms chemical symbol, that 16.00 under oxygen, that means that 1 atom of oxygen is 16 atomic mass units, but it also means that it tells you how many grams you would need to make a mole. So 1 mole of oxygen is 16 grams. 1 mole of nitrogen is 14.01 grams. And so for the glucose, if we need 6 carbon atoms and we wanted a mole of those, you have to think of it a little bit differently. A mole of 6 carbon atoms would be 6 times 1. In case that's confusing, let me think of it this way. So if you want to know the price of an egg versus the price of a dozen eggs, when you ask for the dozen eggs, you have to multiply whatever the price of 1 egg is by 12. This is kind of the same idea. If we want to know the mass of 1 mole of carbon, it's 12.01. But if we want to know the mass of a mole of carbon, 6 carbon, like a set of 6 carbon atoms, and we want a mole of that, what we really have is 6 times what a mole of 1 carbon is. Anyways, the point is that when you get the AMU of the mass in AMU of one of these, that number is also what the mass would be if you had a mole of those things. And so the answer to the second question is simply the same number. So if we wanted a mole of glucose, we would have, to get a mole, we would have to have that same number, but in grams. So two things we need to remember from this is you find the number that you need under the symbol, and when you multiply by however many atoms you have, in this case it was 6 and 12 and 6, you don't use the multiplication rules, you use the addition rules. So your answer is still going to have the same number of, well, not the same number, but the same precision level of significant digits. So if it goes to the hundredths place, which is pretty much all of our periodic table, all of them go to the hundredths place that we're going to be working with this year. And so when you multiply by a number, your answer should still be to the hundredths place for this part of the problem. When you use the number for other things later, then you'll have to deal with significant figures in those problems in a different way. But just figuring out the mass, it's probably going to always be to the hundredths because that's what our chart is.